Lesson 2.2 introduces truth tables. The truth value of a proposition is basically whether the statement is true or false. Often we may not know if a proposition is true or false. When the truth value is unknown, we've got to complete a truth table for the proposition. The truth table is a table or a chart that lists all the truth values for all possible cases for that proposition. It's all of our possible options for truth values. For example, let's consider the conjunction P and Q. Well, I don't know what P is and I don't know what Q is, so I don't know if they are true or false. What I do know from the previous lesson, we know the conjunction, the and, is only true when P and Q are both true. And as I mentioned before, I don't know if P and Q are true or if they're false. So we're going to set up a truth table. And this table is going to show us all the possible combinations. When you set up a truth table, you need to be consistent. This is the way you're going to do it every time. Always list P first, and that's your first proposition, and always list Q second. When there's two propositions, the values for P will always be true, true, false, false. The values for Q will alternate, true, false, true, false. Technically, you can set up your table any way as long as you have these four combinations. However, for grading purposes for this course, you must set up every table in this order. So if we look in the first line, I've got the combination of both propositions being true. In the next two lines, I've got the combination of one proposition being true and the other one false. In the second line, P is true, Q is false, and then I have Q is true and P is false. And then finally I have the combination of them both being false. These are my only options, so there's four outcomes, or there's four cases that I have to consider. Well, as I mentioned before, the conjunction is only true, and is only true when P and Q are both true. So P and Q is only true in that first line. It's false everywhere else. Anytime you're completing a truth value for P and Q, it's only true when they're both true, and it's false everywhere else. Now, before continuing this section, you've got to make sure you've completed the project on truth tables. The project on truth tables goes along with this section, and it helps you as you walk through the process of setting up a truth value. That project basically teaches you when to know when each connective is true and when it's false. When I go through these notes, I'm assuming you've completed the project on truth tables. And you might want to have that project out beside you as you complete these notes so you can refer back to it. And again, to understand these notes, you've got to be familiar with the basic truth values for the common connectives studied in that project. And this is something you will have to memorize. Let's look at completing a truth table. Once you learn the basic definitions, you apply them to harder problems. In more complex problems, you will not have a P and a Q on each side of the connective. You're going to have some other expression. But the basic definitions apply. So let's create a truth table for not P or P. This time I just have one variable. So this is a two-line truth table. So I always start with P. Even though the not P came first, you always start with the basic proposition P. Once I list my P, I'm going to list not P. And then finally, I'm going to find not P or P. Well, since I just have one variable, there's only two possibilities. P could either be true or it could be false. So those are my two possibilities, or my two cases. Not P has the opposite truth value of P. So if P is true, not P is false. If P is false, not P is true. Now you look at the connective. This time the connective is an OR. And if you remember, OR is true if either part in front of it or behind it is true. OR is false if both parts are false. So in front of my OR, I have a not P. Behind my OR, I have a P. So in the first line, my not P is false and my P is true. I have a value that's true, so P, not P or P, is going to be true. In the second case, my not P is true and my P is false. So I have true or false. Since I have a true, my not P or P is true. So if either the statement in front of the or behind the or is true, then the or is going to be true. Next, let's look at the truth value for not P or Q. This time I have two propositions. So this is my table with 4 cases. You're always going to start out with P and Q in that order. Then if you look at your problem, I need a column for not P, so I'm going to put it next. And then I need a column for my overall compound proposition, not P or Q. Now I fill in the basic combinations for P and Q. P is always true, true, false, false, and Q alternates true, false when there's 2 variables. Now I fill in the column for not P. Not P has the opposite truth value of P. So look at your column for P. It's true, true, false, false. So I do the opposite each time for not P. For not P, I'm going to have false, false, true, true. Now finally, I want to find not P or Q. In front of the symbol is a not P, and behind it is a Q. So those are the columns I'm going to compare. I'm going to compare the not P and the Q. If you remember, there was only one case when OR was false, and it may be easier to remember that one case. OR is false when both parts are false. So if I look at line 2 of my truth table, not P is false and the Q is false. So my not P or Q is going to be false. In every other case, at least one of them was true. So all other cases, my OR is going to be true. So my final column for not P or Q is true, false, true, true. In the next example, let's look at not P and not Q. I have 2 propositions, a P and a Q, so I'm going to create a 4-line table. I always start out with P and Q. In this case, I have the negation of each one, so I need a column for not P and a column for not Q. And then finally, I can find my and, so I need a column for not P and not Q. So begin with the standard truth values for P and Q. P is true, true, false, false. Q is true, false, true, false. Now to find my not P, I look at the column for P. And I'm going to change these truth values. I take the opposite. Since P was true, true, false, false, not P is false, false, true, true. Next, for not Q, I look at my column for Q. Q is true, false, true, false. I change each of these, so not Q would be false, true, false, true. And finally, for the AND, I compare what's in front of the AND symbol and what's behind the AND symbol. In front of the AND symbol is a not P. Behind the AND symbol is a not Q. If you remember, AND was only true in one case, and that was when both parts, what was in front of it and what was behind it, was true. So this time, not P and not Q are both true in the fourth line of my truth box. So the fourth line of that column is going to be true. Every other case is going to be false because either the not P or the not Q was false. So my final column for not P and not Q is false, 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 true. Next, I want a truth table for not P and Q. With the use of parentheses, you can treat these just like the order of operations back in any math class. I do what's inside the parenthesis first, and then take care of any symbols outside of it. So I have two propositions, the P and the Q, so I need a 4-line truth table. Always begin with P and Q. Now take care of what's inside the parentheses. I have a P and Q. And then finally, after I find P and Q, I'm going to take the negation of that. So I need a column for not P and Q. So the basic truths for P and Q: P is true, true, false, false. Q is true, false, true, false. Now when I'm finding the AND, in front of it is a P and behind it is a Q. So I'm going to compare my columns for P and Q. AND is only true when they're both true. So P and Q are both true in the first line. So the first line of the P and Q column has a T for true. In every other case, either P or Q or both were false. So in my AND column, the last 3 lines are all false. Next, I look at the negation. Since I'm negating P and Q, I look at my column for P and Q. The negation has the opposite truth values of these. So if P and Q is true, false, 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 not P and Q is false, true, true, true. So the final column for not P and Q is false, true, true, true. In the next example, I want the truth table for P or Q and not P. So if you look at this, I basically have 2 parentheses. I have a P or a Q, and then I have a not P. I'm going to need to find each of these and then connect those with an AND. So I kind of look for a central symbol. The symbol in the middle is that AND. It's connecting the P or Q with the not P. So I'm going to need columns for all of these. Always begin with the P and then the Q. Then in my first parenthesis, I have a P or Q, so I need a column for P or Q. In the second parenthesis, I have a not P, so I need a column for not P. And then finally, I connect these two with an AND, so I need a column for P or Q and not P. We'll start with your basic values for P and Q. P is true, true, false, false. Q is true, false, true, false. Next, I find my values for OR. I'm connecting P and Q with the OR, so I look at the columns for P and Q. OR is only false when they're both false. So if I look at the last line of my truth value, P and Q are both false, so that's where my OR is false. And it's going to be true every other time. So P or Q is true, 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 false. Now for not P, for the negation of P, I look at the P column. P is true, true, false, false. The negation is the opposite of these values, so not P is false, false, true, true. Finally, I'm doing my overall compound proposition with an AND. Before the AND is the P or Q, and after the AND is the not P. So I'm going to compare these two columns. AND is only true when they're both true. So these two columns are both true in the third row. In every other row, I've got at least one of those being false. So they would be false. So P or Q and not P is false, false, true, false. In the final example, I have Q and then the exclusive OR, P and not Q. Since I have two values, I need the 4-line truth table. Always begin with your P and your Q. I notice that in the parenthesis I have a not Q, so I'm going to need a column for not Q. The parenthesis is P and not Q, so I need a column for P and not Q. And then I can do my overall connective, Q or P and not Q, and that's an exclusive OR. So begin with your truth values for P and Q. P is true, true, false, false. Q is true, false, true, false. Next, for not Q, look at your Q column. Q is true, false, true, false. So the negation of this would be false, true, false, true. Now I want P and not Q. So look at your P column and compare that to your not Q column. I'm joining these with an AND. AND is only true when they're both true. So P and not Q are both true in the second line. So I put a true in my second line and a false everywhere else. So P and not Q is false, true, false, false. And then finally, for the exclusive OR, in front of it is a Q, and behind it is P and not Q. So I compare those columns. The exclusive OR is true when only one of those values is true. It's false when they're either both true or both false. So if I look at my last line, I've got Q and P and not Q are both false. So my exclusive OR would be false. In the first three lines, I have one of those values as true and the other as false. So the exclusive OR is true in those cases. So Q OR, not P and Q, is true, 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 false. Now let's look at an example with three propositions. This example has a P, a Q, and an R. I want to create a truth table for P and R, or not Q. When I have three propositions, my truth table is going to have 8 lines. So I begin with the P, Q, and the R. Now if I look, my central symbol is this OR. It's separating the two parentheses. Before the OR, I have a P and an R. So I know my table is going to need a column for P and R. Following the OR, I have a not Q. So I need a column for not Q. Once I have these two columns, I can compare them with an OR. So my final column is going to be the original statement, the P and R, or not Q. When I have three propositions, the truth values for P are half true and half false. So I have 4 trues followed by 4 falses. So the lines 1 through 4 are true and lines 5 through 8 are false. The Q is going to alternate true and false 2 at a time. So I'm going to have true, true, false, false, true, true, false, false. The R is going to alternate true and false 1 at a time. So I'm going to have true, false, true, false, true, false, true, false. Now I compare the P and the R. So look at your columns for P and your column for R. And is only true when these are both true. In my first row, the P and the R are both true. Also, in my third row, the P and the R are both true. So the AND is true in rows 1 and row 3. In all my other rows, either the P or the R is false. So it's going to be false everywhere else. So for the AND, look at where they're both true. And that's when your AND is true, and it's false everywhere else. For not Q, I'm going to take the opposite values of Q. Q is true, true, false, false, true, true, false, false. So not Q is false, false, true, true, false, false, true, true. Now for my final column, I want the OR. In front of it is my column for P and R. Following it is not Q. So I compare these two columns. OR is only false when these are both false. So the P and R and the not Q are both false 3 times in this table. In row 2, row 5, and row 6. So that's when the OR is false, in rows 2, 5, and 6. It's going to be true everywhere else. If at least one of those values is true, my OR is true. Now for our final example, I have P or not Q and not R or Q. So I have 3 propositions, the P, the Q, and the R. So I need to set up my initial table with my values for P, Q, and R. The P was true for the first 4 rows, false for the last 4. The Q alternates true and false 2 at a time, and the R alternates true and false 1 at a time. Now look at your original statement. In the middle, I have an AND. That and is separating two parentheses. So I need to build the first parenthesis in my table and then build the second parenthesis in my table. Then I can compare those columns with an and. My first parenthesis has a P or not Q. I know I'm going to need a not Q in my table. Once I have my not Q, I can find my P or not Q. But while I'm finding my not Q, I'm going to go ahead and look at the second parenthesis and list my not R. Since these are both negations, it's just going to be easier to list them first. Then when I have my negations, I can find the parentheses. The first one is the P or not Q, and the second one is the not R or Q. The order of the individual columns in your truth table does not matter. You can complete these in any order. So if I had found my not Q and then went ahead and found my P or not Q, that would have been fine. It's just your final column always needs to be the original statement. This is what you're going to give the answer to for your quizzes and your test, is the final column. So that final column should always be the original statement. Now let's find the two negations. For not Q, I take the opposite of Q. So I'm going to have false, false, true, true, false, false, true, true. For not R, I'm going to take the opposite of R. So I'm going to have false, true, false, true, false, true, false, true. Next, for P or not Q, I'm comparing my P column to my not Q column. I compare these with an OR. OR is only false when they're both false. So look at these two columns. These two columns are both false in rows 5 and rows 6. So the P or not Q is false in rows 5 and 6. This means it's going to be true everywhere else. Next, I have not R or Q. So compare your not R column with your Q column. And again, OR is only false when both of these are false. Both of these are false in rows 3 and rows 7. So not R or Q is false in rows 3 and row 7. So it's true everywhere else. Then finally, I'm looking at my AND. So I'm comparing P or not Q with the column for not R or Q. AND is only true when these are both true. These were both true in rows 1, 2, 4, and 8. So rows 1, 2, 4, and 8 in my final column are true. The AND is false everywhere else, so fill in your falses.